Welcome back. We're going to continue the video series as we get ready for our final exam. This video will focus on problems from Unit 9, Installment Buying. Starts with number 11. Yeah, Barney 5, clever name. Going to buy a sofa. Purchase price at $2,500 if he's got the cash up front. If he doesn't, he can make a series of payments, $250 for 12 monthly payments, along with a down payment of $800. Question says, how much is his finance charge? So it's a straight through attack. You're going to take the 250 times 12. That'll find out how much he pays over that series of payments. Remember, he also has to pay the $800 down, so that would calculate his finance price. He could have bought the thing for $2,500 cash, so the difference between those values will represent his finance charge, or how much he pays for the use of someone else's money over that series of 12 payments. The answer amounts to $1,300 on number 11. No biggie. Straight multiply, big old add, and a takeaway. Problem number 12. We're going to calculate an average daily balance for a revolving charge card. We're going to assume a 30-day billing cycle. So what we've done here is we've created a little chart that hopefully you can see. We get the number of days of a current balance, the actual current balance, and then that extension column on the right is simply a product. So you're going to wind up multiplying the number of days times the balance for that many days to get an extension. To calculate the average daily balance, we'll then sum the first and third columns and do a divide. So if you look at the original problem, the billing date at 3/19, your previous balance is $900. That remains the balance until the 26th. So that's why there are 7 days from the 19th to the 26th, and a $400 payment was made, and that diminished the balance from $900 to $400, and it stayed that until the next charge, which was made on the 30th, which was 4 days after the 26th. All right, so when we just made another charge, so that took us from $500 up to $700 in terms of the amount we owe. All right, stays that until the next change in the account, which happens on 4/4, and that's a payment. Well, that's 5 days have passed, 1 to get to the end of March, and then 4 more to get us into the next month. So 5 days, and that's a $100 payment. So our $700 balance gets knocked down by 1 and becomes $600, and it stays that from the 4th to the 14th. So we have a $600 balance owed for a span of 10 days. And then last but not least, the last entry in this chart reflects the fact that we have to account for a 30-day balance, a 30-day window. And if we look at the number of days we've already accumulated, we've got 7 and 4 and 5 and 10, total of 26. So if we're tracking a 30-day window, that would mean for the last 4 days of those 30, our balance reflected the $900. And as I said, here's going to be your calculation for average daily balance. Sum the number of days. So we already knew that was 30. Sum that right side column, get your total, what, 20,800. The average daily balance then is that division. It's the 20,800 divided by 30. So the average daily balance on this account turns out to be $693.33. The chart makes it useful. Realize that the current daily balance changes with every impact on the credit card account, whether it be a payment or a charge. Let's move to 13. All right, Jack's going to buy a computer on 13. He's going to make a payment. And what you need to remember on this is, as we've seen previously, that when you make the payment, the first part of that payment goes to account for interest, and any amount above that defrays the principal. So in this particular problem on number 13, the purchase price of the car was, the purchase of the computer was $2,499. And he's going to pay $400 a month until he pays it off. So that first $400 payment kicks in, and we're going to calculate the amount of interest. And the amount of interest is at 1.5% per month. So you're going to take $2,499 times 0.015, and that's $37.49. So of the $400 payment, $37.49 goes for interest. The rest goes to pay back what you borrowed. So we'll take the $400 and we'll take off the $37.49. And we'll realize that that means $362.51 goes to defray the cost of the loan, and the balance at the end of that first month is the original $24.99, which is what we borrowed, minus the $362.51, which in effect was a repayment of amount borrowed based on that first monthly payment. So at the end of month number 1, we no longer owe $2,499. We now owe $2,136.49. Remember, in this context, interest comes first. The balance of that $400 payment, I should say, went to defray the amount that we borrowed from the $2,499. Number 14 is going to ask us to calculate how much the payment is for this particular car transaction. All right, we've got an $18,000 car, 20% down. So the first thing you'll see on the screen is I chose to find 80% of 18,000, and that would tell us how much we were borrowing. And that's how we got to the 14,400 number. That is the present value for this loan. And we're going to be calculating the payment. The interest charge for 60 months at 8%, you're going to have to calculate the interest charge per month. That's why you see the 0.08 divided by 12 up there to 0.006 repetem. And that's the interest rate for each month. So plugging values in, present value of the loan, 14,400. The interest charge is that 0.006. I chose to write it in the 0.08 over 12 because I just let the calculator handle it accurately. So that's what you see on your screen. N is the number of monthly payments. That's 60. Calculator attack. I think you're better served calculating the denominator first, working a single value out of it, storing it in memory, and then taking your numerator, doing the arithmetic. Again, for me personally, I'm going to take 14,400 times 0.08 and then just divide that result by 12, gets me my numerator value. Then I'll divide by a recall on my memory. I think you're going to be better served calculating the denominator first, storing it, and then go ahead and doing it as a single divide. At the end of all the singing and dancing, we find out that the amount that we will pay each month for that loan, $291.98. And that is calculation of a monthly payment. I think we'll see it again when we get to unit number 10. So it's a very cumbersome looking formula, but it's not that hard to deal with. It's got how much is the loan worth, that's your present value. What's the interest charge in this case per month, and then how many months in terms of payments. And that, my friends, wraps the unit set for 9, and we'll be back soon with a video for unit number 10. See you then.